All right, good morning, guys. Hi, everyone. We are looking at our, still looking at our semester review, but today we're going to visit chapter 2. This was the logic section that looked at your different kinds of reasoning and your different kinds of statements that we can make. And then also, how do we use all of this with our different mathematical and geometric properties that we worked with. So let's start off with our reasoning and just review that for a little bit. So the first one we have is inductive reasoning. Okay, inductive reasoning, there we go, is conjecture that is reached based on observations. Okay, observations of patterns. So are you adding the same thing each time in this pattern, or maybe are you multiplying by the same number for each pattern? Any kind of specific pattern that you can make off of a group of things, whether it's objects or numbers, things like that. And then we have deductive reasoning. Deductive reasoning is a conjecture that's based off of definitions. So is there a definition or a fact in the situation that you need to know prior to making that conjecture? All right. So for example, if I look out the window and see a red car driving by, and then another red car, and then another, and then another, and then another, inductive reasoning lets me make a conjecture that the 10th car would be red to drive by because the pattern was red cars. Okay, nothing in that conjecture, in that statement, do you need to know a vocabulary word for, or do you need to know a previous fact? Now, deductive reasoning. If I was to say if a pair of angles are a linear pair, then they are supplementary. That is deductive, because if you don't know the definition of linear pair or the definition of supplementary or what those facts mean, then you don't know how to make anything out of that conjecture. You won't know what it means. So again, in the situation, if there's a definition or a fact that you have to know prior, that is deductive reasoning. Inductive reasoning, you can make a pattern without needing any prior knowledge, prior definitions. Again, it's just based on observations of patterns. All right, now when it comes to inductive or deductive reasoning, that leads us into what's called a counterexample. Again, this is an example that proves a conjecture is false. So an example that proves a statement is false. So for example, we have here, we're going to make a counterexample for the statement, if an angle is obtuse, then it measures 100 degrees. So somebody tried to make this conjecture using deductive, because again, what is the definition of obtuse? If you don't know obtuse, you don't know what this statement is referring to. Now this, remember, for a statement to be true, it must be true 100% of the time, every single time the statement is made. So for this example, start at the beginning. Angle is obtuse. Well, that's any number, any angle measure bigger than 90 degrees, but less than 180. The clue here is it's any number that fits that definition. So this statement, again, read it as if an angle is obtuse, then it only measures 100 degrees. That is a false statement, because we can have any other angles that are bigger than bigger than 90 and less than 180. So yes, 100 is obtuse, but there are infinitely many more obtuse angles out there. We could have an angle that is 95. We could have one that's 101, 179. Any number that is bigger than 90 but less than 180 is considered obtuse. So again, that's what makes the 95, 101, 179 counter examples, because they prove that sentence wrong. Not every obtuse angle is going to be 100 degrees. All right. From there, we wrote out what were called our conditional statements. And remember, this is a statement that is in the setup of if, then. Oops, sorry, that's a little small. There we go. An if, then statement. Okay. Now remember that we had the setup if P, then Q. So P and Q just represent different phrases. Okay, P is its own phrase, Q is its own phrase, and they've been put together in one big sentence. So we talked about how P is the hypothesis. So if your hypothesis, and we said Q was the conclusion. So if your hypothesis, then your conclusion. But using that conditional statement, we came up with 3 other variations off of it. So for example, we have the conditional statement, if a triangle has 3 congruent sides, then it's equilateral. So the first version of this that we looked at was converse, which meant to switch the 2 phrases. So we're going to switch out the hypothesis. So there is the P statement. It's equilateral, or it is equilateral, is my Q statement. And again, we physically swap out those phrases. So the if stays put. So if the conclusion comes first, it's equilateral. Then stays where it is. We finish it up with the original hypothesis. So then a triangle has 3 congruent sides. And there is our converse. And again, notice all that happened was the 2 phrases swapped places. Excuse me. Next, we had inverse. Inverse was to negate, which meant to take the opposite of. Now, we talked about the opposite, meaning that we can either add or remove the word not. So we can add or remove not. Okay, and all of that was for the inverse. So we're either going to put the word not in there to show opposite, or we will remove it in case it's already there. So again, we start off with if. This time, the order of the statement does not change. So originally, if a triangle has 3 congruent sides, so if a triangle does not, there's my negation. Have 3 congruent sides. Our then is still at the end. Then we go again, we have our original conclusion that was it's equilateral, then it's not equilateral. And again, there's our negation. Again, this one, the order does not change, but the only thing that happened is we put in, again, the word not there. All right, now contrapositive. Contrapositive is the one where you do both. You switch and negate. So switch and take the opposite. And again, so that we don't forget, negate means opposite. I'm going to write it in there. Bear with me for just a second. I'm going to move this over. Okay. All right, so we start off with the same if. We need the opposite of the conclusion to be first. So we've got it over here. It's not equilateral. So again, there's the negation for the switch. Then a triangle does not have three congruent sides. And again, there is our negation for that part. I'm just going to do it down here at the end. Okay, so now we can see as a whole, when we put this one back up, again, if it's not equilateral, then a triangle does not have three congruent sides. All right, so those are our three phrases. So it's all about what's happening. Do you just have to switch them? Do you have to do the opposite of the statements, or do you have to do both? So again, be very careful, make sure you know which one you need to do. Now, we also had in this section some properties to review. Now, listen carefully to me because these are not the only properties you might see. The ones that are in this review are just the commonly missed ones that I want to make sure we're good with, because there were also all the properties on operations. All right, so the first thing we had was the reflexive property. The reflexive property says from one side to the other, there is no change. Sorry, I'm going to make this a little bit better. There's no change happening from one side to the other. Next, we had the symmetric property. Symmetric property, excuse me, said from one side to the other. The only thing that happened was they switched places or switched the order. If A equals B, then switch the order, B equals A. Next, we had the transitive property. So again, we go from the whole entire beginning to the end. And remember, the only thing that happened from beginning to end was we removed repeated information. And that's why these are marked out, because it is repeated. Hence, we remove it. All right, next one down, we had the definition of midpoint. So remember, with definition of midpoint, we are making two congruent parts. So we could have something that looks like, excuse me, part 1 congruent to part 2, or you could have part 1 equal to part 2. Those are all variations off of the midpoint formula. Now, our last property that's down here is the midpoint. I'm sorry, not midpoint, the definition of congruence property. And this one could go two different ways. So one way says we can start with our statement being two things are congruent and move to say that then they must be equal. Or we can start off with equal and then use that to find the two congruent pieces. So definition of congruence lets you say that things are congruent and then you move and replace that with equal. Or you start with equal and change it to they must be congruent. Okay, so guys, I hope you remembered, I hope you can remember about these different properties. Some other ones that I want to make sure you remember but aren't necessarily on here, because again, the ones on these on this review are the most commonly missed. But remember, you also have all of your operation properties. So you also, I want you guys to also go and revisit the addition property, which said you could add the same thing to both sides. The subtraction property, which said you can subtract the same thing to both sides. And then you also had multiply or divide. Your multiplication property said you can multiply the same thing to both sides. And then your division property, which said you can divide by the same amount on both sides. And again, by both sides means both sides of your property or your equation. We use those operation properties a lot when we solved out equations. Okay, so guys, please make sure you revisit those 4, but the ones on the review, like I said, those were the most commonly missed, the ones that are in the table there. So please, always in your best interest, guys, to go back and revisit all of the different properties that we covered. I just tried to hit the highlights here. So guys, please don't hesitate to reach out to me if you have any questions at all. Have a great rest of your day, guys.